Hi everyone, Mr. Bowman, and in this free response problem, we're going to focus on slope fields and differential equations. So the differential equation is given to us, and we need to, in part A, sketch a slope field for the given differential equation at the 6 points indicated. Remember what the slope field is. If we were given an initial condition, we would be able to draw a curve that includes that point, that initial condition, and the points in the slope field are the slopes of the tangent lines to that solution at those points. So let's get started with this. We'll start at the point 0, 0. So we're just going to plug 0 in for y, 0 in for x. So we get 0 over -1, which is 0. Then we're going to move up to the point 0, 1. So y squared is 1, x is 0, so 1 over -1 is -1. And then we're going to move up to the point 0, 2. So 2 squared is 4 over -1, which is -4. So make that obvious that it's steeper than the one below it. Then we'll jump over to the point 2, 0. So our numerator is going to be 0. Our denominator is going to be 1. So we have a slope of 0. Then over to the point 2, 1. So we have 1 over 1, which is +1. And then up to the point 2, 2. So we have 2 squared over 1, which is +4, so make that more obvious. As far as the scoring is concerned on that, you get 2 points, one for the 0 slopes and one for the non-zero slopes. In part B, they say let y equal f of x be the particular solution to the given differential equation with the initial condition f of 2 is equal to 3. Write an equation for the line tangent to the graph of y at x equal 2, use your equation to approximate f of 2.1. Okay, so there's a lot going on here in part B. We need a point on the curve of f. We know that. That is the point 2, 3. And we also need to find the derivative at that point. dy dx is equal to y squared over x minus 1. Notice this depends on both the x and the y coordinates at that point. So we're going to put this notation here that says we're going to evaluate that derivative at the point 2, 3. So we get 9 over 1, or 9, for our slope. So our equation of our tangent line, y minus 3, is equal to 9 times x minus 2. And we are going to use that to estimate f of 2.1. So f of 2.1 is approximately equal to y of 2.1, which is going to be equal to 9 times 2.1 minus 2 plus 3, and if we simplify that, we get 0.9 plus 3, or 3.9. As far as the scoring is concerned, you get 1 point for the tangent line equation and 1 point for the approximation. So we've got a total of 4 out of the 9 points accounted for. Again, part C is big points. So do as much of that as you can, even if you don't know how to solve the whole thing. Find the particular solution to the given equation with the initial condition f of 2 is equal to 3. So the point 2, 3 is on the curve of our solution. Again, we have a separable differential equation. dy dx is equal to y squared over x minus 1. And if we were to separate this, so the y's and the y squareds are on one, the y's and the dy's are on one side and the x's and the dx's are on another, what we would get is dy over y squared is equal to dx over x minus 1. You can do the math to figure that out, and then we're going to integrate both sides of that. If you're struggling recognizing what those antiderivatives are, you might consider rewriting it like this. 1 over y squared dy is equal to integral of 1 over x minus 1 dx. You might even want to, with this one on the left, write it as y to the negative 2 dy is equal to the integral of 1 over x minus 1 dx. Okay, so when we antidifferentiate the left-hand side, the exponent goes up by 1, so y to the negative 1, but when we differentiate that, we need that negative to cancel out, so we're going to have a negative 1 out in front there. Don't forget the constant of integration. On the right-hand side, we are going to have the natural log of the absolute value of x minus 1. All right, 1 point for the separation of variables. 2 points for the antiderivative. So we have 3 out of our 5 accounted for there. Next, we have to find C. We know that the solution contains the point 2,3 called the initial condition, so we're going to plug that in. So negative 1 over 3 plus C is equal to the natural log of the absolute value of 2 minus 1. Well, that's natural log of 1, and natural log of 1 is 0, so C is equal to positive 1/3. Constant of integration and uses the initial condition gives us another point there, so the last thing we're going to have to do is solve this for y. So we go back to our original equation. Negative 1 over y plus 1/3 is equal to the natural log of the absolute value of x minus 1. All right, this should be relatively easy to do. So negative 1 over y is equal to natural log of the absolute value of x minus 1 minus 1/3. And then we could solve this various ways. I would probably multiply both sides by negative 1. So you have 1 over y is equal to the 1/3 minus the natural log of the absolute value of x minus 1, and then take the reciprocal of both sides. So y is equal to 1 over 1/3 minus the natural log of the absolute value of x minus 1. We'll take a look at the solution here. It's probably going to be in a slightly different form, but that should not matter. And their solution, they have 1 over 1/3 minus the natural log of x minus 1. And they do not have an absolute value in there. I don't know why that would be the case, but it says you solve for y. Having the absolute value in there is not going to lose you a point.